In this video, we are going to be discussing the rational zero theorem, sometimes referred to as the rational root theorem. So, the rational zero theorem is any rational zero of a polynomial must be of the form plus or minus p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. So, remember that a rational zero is a rational number. So any rational number that is an x-intercept, it will always be of the form plus or minus p over q, where p is a factor of the constant and q is a factor of the leading coefficient. We call all plus or minus q values possible rational zeros, or PRZs for short. So on these first two examples, it says list all the possible rational zeros for each function. So the first thing you want to do is you want to make sure that your polynomial is written in standard form, and it is. Your constant is just that, the constant. So my constant is 15. You don't have to worry about the negatives because all of our answers are going to be plus or minus. And then we're going to also need our leading coefficient. Our leading coefficient is a number in front of x to the fourth, so that's 1. So what we want to do now is list all of the factors of 15 and 1. So numbers that multiply to 15 are 1 times 15 and 3 times 5. Numbers that multiply to 1 are just 1 times 1. Your possible rational zeros are always your constant factors divided by your leading coefficient factors. So here, they're always plus or minus. I'm going to do constant divided by leading. So 1 divided by 1 is 1. And then I'm going to do the next one. 3 divided by 1 is 1. 5 divided by 1 is 1. And 15 divided by 1 is 15. These are my possible rational zeros. So what they're saying is, if I were to solve this equation, these are possible answers. It's always plus or minus. You do each constant factor divided by each leading coefficient. Let's try that again with this one. On g of x, I have 3x cubed minus 11x squared plus 12x plus 4. Our constant is our p-value. Here, our constant is 4. The factors of 4 are 1 times 4 and 2 times 2. My leading coefficient q is 3. Factors of 3 are 1 times 3. So again, we're going to do constant divided by leading. That's how you always do it. So 1 divided, I'm going to do all of these divided by 1, and then I'm going to do all of these divided by 3. So 1 divided by 1 is plus or minus 1. 2 divided by 1 is 2. 2 divided by 1 is 2. We already have that. 4 divided by 1 is 4. Now I'm going to do the same thing for 3. 1 divided by 3 is 1/3. 2 divided by 3 is 3/2. 2 divided by 3 is 3/2. And 4 divided by 3. Whoops, here I did that one backwards. 2 divided by 3 is 2/3. Sorry about that. And then 4 divided by 3 is 4/3. So these are our possible rational zeros for the function g of x. So let's try this with example 1. Example 1 says find all of the rational zeros for the function h of x equals x cubed minus x squared minus 8x plus 12. Step 1 is to find all of the possible rational zeros. So this is when you do constant divided by leading. So what is my constant? My constant is 12. The factors of 12 are 1 times 12, 2 times 6, and 3 times 4. My leading coefficient is 1. Factors of 1 are just 1. So to find my possible rational zeros, I'm going to have each one of these divided by 1. So 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 divided by 1 is 6. And 12 divided by 1 is 12. So these are our possible rational zeros. And again, to find these, I did my constant factors dividing by my leading coefficient factors. Step 2 says to use synthetic division to find a zero. So remember, your remainder must be 0. So what we're going to do is we are going to pull from our possible rational zeros and we are going to do synthetic division. If we get the remainder is 0, then that number is a solution. So that number is a 0. And then I can use that to factor. So I always like to start with 1 if 1 is a possible rational zero, and it is here, because 1 is a nice, easy number to multiply by. So I'm going to try 1. So 1 is going to be up here for my synthetic division. My coefficients are 1, -1, -8, and positive 12. And again, I'm getting those coefficients from right here in h of x. You always bring down your first coefficient, and whatever's last is your remainder. So let's see. 1 times 1 is 1. -1 plus 1 is 0. 1 times 0 is 0. -8 plus 0 is -8. 1 times -8 is -8. 12 minus 8 is 4. Did we get 0? No. So this is not a 0. So let's try another number from our possible rational zeros. I'm going to try 2. So 2 is going to be the number that goes up here. And then again, my coefficients are 1, -1, -8, and 12. Always bring down your first term. And whatever I get here is my remainder. 2 times 1 is 2. -1 plus 2 is 1. 2 times 1 is 2. -8 plus 2 is -6. 2 times -6 is -12. 12 plus -12 is 0. This one is a 0. So we can use this to help us factor. So if 2 is a solution, then that means x minus 2 is a factor. Let me write that so that it actually says what I want it to, x minus 2. And then here, we started with x cubed, so this is going to be x squared, x to the first, and x to the 0th power. So right here, I'm going to get x squared. Let me just give myself some more room here. I'm going to have, this is x squared, x to the first, x to the 0. So right here, this gives me x squared plus x minus 6. So I've factored. Step 4 is to factor completely. So we want only linear factors. So x minus 2 is a linear factor. And when I look at this, I can factor this trinomial more, right? So let's use the area model to factor that. First term goes in the first box, last term goes in the last box. I'm looking for two numbers that multiply to -6 and that add to 1. And again, that's because 1 times -6 is -6, and 1 is the coefficient of my middle term. So those two numbers are, let's see, +3 and -2. So on the top box, my GCF is x. In my bottom row, my GCF is -2. On the left side, my GCF is x. And on the right side, my GCF is 3. So this factors down to x minus 2 times x plus 3. If we look at step 5 says to set each factor equal to 0 and solve. So it's like I have my 3 factors here. Those 3 factors are x minus 2 equals 0. And then I have x minus 2 equals 0 and x plus 3 equals 0. So to solve this equation, I'll add 2 to both sides and get x equals 2. Over here, I'll add 2 to both sides and get x equals 2. And on this last equation, I'll subtract 3 and get x equals -3. So my answer is that I have x equals 2 with a multiplicity of 2, and I have x equals -3. These are my solutions. Let's look at example 2. It has the same steps, the same thing that happened in example 1 is happening here. So it says to state all possible solutions, all possible rational zeros for b of x equals 4x cubed minus x, or plus x squared minus 4x minus 1. Factor completely. Find, this should not say final, that should say find all rational zeros and sketch the graph. So up first is to find the possible rational zeros. So again, this is when you do constant divided by leading. Here my constant is 1. The factors of 1 are just 1. And my leading coefficient is 4. The factors of 4 are 1 times 4 and 2 times 2. So my possible rational zeros, we do constant divided by leading. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. 1 divided by 4 is 1/4. These are my possible rational zeros. Now we're going to use these possible rational zeros to find an actual zero. So step 2 says use synthetic division to find a zero. And keep in mind that your remainder must be 0 for it to be a 0. That's where it gets its name from. I want to start nice and easy. Let's start with 1 before we start doing this with fractions. My polynomial is in standard form and it is not missing anything. So those coefficients are 4, 1, -4, and -1. I'm going to bring down that 4. And whatever I get here is my remainder. So let's see. 1 times 4 is 4. 1 plus 4 is 5. 1 times 5 is 5. -4 plus 5 is 1. 1 times 1 is 1. -1 plus 1 is 0. So here we have my first factor of, so this is a 0, right? Because we got 0 as our remainder, so that's good. So if 1 works, that means that I have x minus 1 as a factor. We started with x cubed, so this is going to be x squared, x to the first, and x to the 0th power. So that's going to be 4x squared plus 5x plus 1. Step 3, write the polynomials as a set of factors. That's what I just did here, so let me just move that down. Step 4 is to factor completely. So this is when you want just linear factors. X minus 1 is linear. Its highest exponent is 1. I need to factor this trinomial completely. To do that, I'm going to use the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. 4 times 1 is 4. So I'm looking for two numbers that multiply to 4 and that add to 5. That's going to be 4 and 1. Remember, order does not matter when you plug into the area model. The greatest common factor of my top row is 4x. The greatest common factor of my bottom row is 1. The greatest common factor of the left column is x. And the greatest common factor of the right column is 1. Remember, with factoring, you can always check your work. 4x times x is 4x squared. 4x times 1 is 4x. 1 times x is 1x. And 1 times 1 is 1. So my factors for this trinomial are 4x plus 1 and x plus 1. Step 5 is to set each factor equal to 0 and solve. So this first factor is going to be x minus 1 equals 0. The second factor will give me 4x plus 1 equals 0. And this last factor will give me x plus 1 equals 0. To solve this first one, I'll add 1 to both sides and get x equals 1. For the second one, I'm going to subtract 1 on both sides and get 4x equals negative 1. Divide both sides by 4 and get x equals negative 1/4. And over here, I'm going to add 1 to both sides to get x equals positive 1. Oops, I'm not going to add, I'm going to subtract. Silly me. To undo addition, we do subtraction. There we go. So my zeros are x equals 1, negative 1/4, and negative 1. The last question says to sketch a graph of the polynomial. Now, with everything that we've learned, we can do this without a calculator, right? So I have negative 1 as a 0, negative 1/4 as a 0, and positive 1 as a 0. My original polynomial is an odd degree, right? If I look at the leading coefficient, it's odd, and it's a positive leading coefficient. So odd and positive tells me that the end behavior is going to look like this. And so I'm going to start down low. I'm going to go up through negative 1, back down through negative 1/4, and back up through positive 1. So it's going to look something like this. Now, if you wanted to, you could use Desmos, but we really don't need to since we just want a sketch of the graph.